All right, now that you have the parser implemented, let's turn our eyes towards the main function. And in main, recall that we set up a scanner to produce tokens, and we gave that scanner to the parser that we just implemented, right? And that parse function moves through the input and ultimately returns to us a node that's on the heap that is either going to be a char node, a pair node, or an error node. We don't know what kind of node yet. And what we're going to do here is we're going to visit that tree that gets returned back to us, right? And then after we're done visiting it and producing some output, and we're just going to print some information to our screen to convince ourselves that we've successfully parsed and come up with the right structure that we expected. We're going to visit each node of that tree, and then after we're done with it, we'll drop it and free it all from memory, right? So in this scaffolding of a function, we still have some work to do. And before we jump into the actual implementation, what I want to do is focus on an example and just sort of lay the context for where we're going. So let's imagine we had input a string like this. What we expect to get back, right, is a pair node whose first value is a char node with the value a in it, and whose right value is another pair node, whose first value or whose left node is going to be a char node with the value b in it, and whose right node is going to be a char node with the value c in it, right? And so this is a rough drawing visual representation of what we expect to have as the parse tree of having parsed this input string, right? And now what we're trying to do is visit that, right? So we're going to implement this visit function, and it's being given a reference in the first call to this root node, right? So the first thing we need to do when we're processing a node is figure out, well, what type of node are we dealing with? Are we dealing with a pair, or are we dealing with a char, or are we dealing with an error, right? Which isn't represented here, but we'll have to handle that as well. So I'm going to jump into the code and let's start by saying, okay, what type of node are we dealing with? And this is a pointer, so I'm going to use the arrow to access the properties of this pointer. So we're going to make a switch statement here, or to access the members. And then what we're going to do is say, okay, the case of a pair node, we want to do something and then we'll break. The case of a char node, do something and then we'll break. So we'll still have more work to do. And then the case of an error node, do something and then we'll break. All right. So we've got these three cases here that we need to do some more work with. So let's actually start with the easiest example here, which is, what do we do with a char node? Well, with a char node, all we're going to do is printf and print char, followed by an open parenthesis and a single quote. So notice this is what the output we're expecting for a char. And after a char, what we're going to print is the character itself. So %c, and then close that out. And what is the character? Where are we getting that character placeholder from? Well, that's coming from node data. And then within the data union, remember, now we have to select which of the union variants are we dealing with. Well, we've got a character node, so we set up the value, which remember was a character value, which is an alias for just a char, right? And so we should be set there. And I'll include a new line here, all right? The next thing that we can handle is, what about a pair node? Well, for a pair node, what we're going to do is printf, and it's going to open up a pair on a new line. And we don't need to output anything else, right? We are effectively saying start a new line with pair. What we're trying to do is produce a pair line of output. And we also need to remember to include a closing parenthesis. And let me do a \n here. And then we need to handle, what about the children of the pair, right? I'm going to come back to that. When we have an error node, the error node type has a value that is a string, right? So maybe we'll just do an fprintf, and we're printing to the standard error output a message of error followed by a string and a new line, And where's that string coming from? Well, it's coming from node data, and then the error node, its union for its node value is in this error field, right? And if we were to look at that, we would have seen that it is, in fact, just a char pointer to a C string that's constant, right? So this will give us the error output, right? So we've made some progress here. And now what about our children, right? Well, this is where recursion happens, right? So if we visit and the node that we visit is a pair, we would reach this case, we would print out pair, and now what we want to do is go visit the left child and do the same process on it, no matter what it is, and same with the right child, right? So we would visit then the right child after the left child. So how can we achieve that? Well, through some recursion, right? And this is what we mean when we're trying to visit or traverse this tree. We are doing it depth first here. So we are going to visit. And what are we visiting? Well, we've got a node whose data is pair, right? We know it's a pair node when we reach this case, and we'll visit the left node first. And then notice that visit has the second argument here, which we haven't discussed or dealt with yet. But the idea is we're going to need to continue indenting some additional spaces. For now, let's just set this as 0, and we'll come back to this. This will be a problem for after we convince ourselves that our recursion is working. Then we're going to visit the pair's right side. And once again, it's 0, right? And I forgot to print f here. I forgot the f of that printf statement. Okay, so it seems like, oops, and I forgot a closing paren down there. All right. So it seems like we've got a rough scaffold of a function that will visit each node in a tree. When we hit a pair, we're going to print off pair and then visit the left side and then the right side. And if we found another pair, we would continue doing that recursively. And with char values and with error nodes, we've got 2 base cases of this recursive function, right? So if I were to try running this, I could make it. And you may get a warning here from, if I were to actually make clean and then make again, you'll notice there's a warning that the variable next in our scanner was unused. And I set this variable up in the scanner in the previous example video, because if you were doing error handling, you would need to check to be sure that that next token is what we expected. But remember, we trusted that the user was going to input the correct things. So we're not checking errors, but you would want that variable in order to check and see, hey, was that next token that I got actually what I expected, right? But our program will run despite that warning. That's just a slight optimization. So I'm going to give the make run command. And now I can try typing in, say, a single char, right? And when I press enter, that value is passed into a char iterator, right? We get a char iterator back. Then that becomes a scanner is built from that char iterator, which produces tokens. That's handed off to our parsing process. And the parser is saying, okay, what's the next thing? Well, it was not a open parenthesis, so we must be parsing a char, and I'm going to result in a char value. Right? And then when we came back to main, we traversed this with the visit function, and that's what is going to get us to move through this example. So let's try something a little bit more interesting, like AB. Well, notice here we have a pair being printed with a char A and B in it. And if we tried the input that was the one that we modeled in our example and that we have over here still visually to the right, notice we have a pair that's made up of a char followed by a pair, which is a char B and char C, right? So this looks very close to what we were trying to do. And the last step that we need to sort of take care of to bring this one home is to add indentation so that this gets to be a little bit more clean and we can see the tree-like structure that we've built up in our parse tree. So I'm going to go back to source main and jump to my visit function. So if I do /visit, this allows me to search by a regular expression. When I press enter, it brings me to the first match of visit. And then if you press N, it brings you to the next match. So this is where we called visit from within main. And then the next is in our comments. And then the next is the actual definition, right? So there's this helper function that I went ahead and set up that's called indent. We give indent function the number of spaces we want to indent, and all it's doing is putting out one character at a time, that many spaces. Right? So let's indent by the number of spaces that this parameter gives us. And initially for main, right, we are indenting with 0 spaces. So there's no indentation. But when we visit, what we want to do is actually increase that spaces parameter by 2, right? So 2 spaces per nested call here, right? So, oops, and I need an S there. So what we can do is increase in our recursive call the number of spaces we indent with, and that'll be great, right? And this is putting spaces in front of the first line of output of whatever our case is going to resolve in, right? So there would be, let's say, 4 spaces before printing this pair. And then when we called visit again, we would have 6 in the recursive call to this visit function. But we actually have one more case we need to handle here, which is with the node, or sorry, with the pair node, we need to indent the closing parenthesis as well. So I'm going to add one more indentation there, right? And so now I've got my implementation of visit, which is going to hopefully indent my output in a way that gives us a better feel for the tree-like structure here, right? So I'm going to make run again. And now let's try that example that we saw before, A, B, C. All right, and notice that the indentation increases each time we see a pair. And if I wanted to, I could give a more interesting set of pairs here. So like AB, maybe BC, and then let's see. So I've got, that's one set of pairs, and then I'll need another, let's just do like say C to end this one, right? And so notice that the structure of our indentation would mirror what we would expect the structure of our parse tree to look like, right? So if I were to get rid of my output here and think about, well, what would this parse tree look like? Well, we're going to have a pair at the top, and it's going to have a left and a right, and that's going to have a pair on the left. So it's another pair here, and that's going to have a left and the right. And that left is going to be another pair with A and B in it. And its right is going to be another pair with B and C in it. And then finally, this top level is just a pair with the value C in it, right? And so this structure that we're seeing output would mirror exactly the internal structure of nodes that we had built up in memory through recursive descent parsing. The next problem that we'll work on in a lab is building a parser for shell commands. And in it, you're going to need to pay more attention to how errors are handled and what happens when an error is handled. In fact, if we wanted to, we could convince ourselves that we could trick this grammar based on not checking for things being correct, right? So let's give just a quick example here. If I had an input like A underscore B, that shouldn't be correct, right? But remember, we didn't check to be sure that that character or the next token after the first node of a pair was anything special. We just took it. We didn't check to see whether it was anything that we needed to care about or not. In fact, even if it were an open paren, which would feel very wrong, we're ignoring that, right? We're not checking to be sure that that was actually a space there. Same with this closing paren, right? And those are error checks that you would want to have in a real parser 100%, right? We wouldn't trust that the next token was the correct one, right? But for now, just to demo that this is taking those characters, moving the scanner forward, parsing out the structure that we expect, as long as we give it the expected inputs, we're okay, right? But I would encourage you to spend some time thinking through how you would implement error handling in this simple care pair example in the parser functions, and being very careful not to leak memory. Because in the case where you've parsed one node successfully, and you've allocated heap memory for it, if you get to a point where you need to error out and return an error token, you need to be sure that you didn't, or that you freed any memory that was allocated part of the way there, right? And that's one of the challenges of implementing error handling in this parser. Great work today. We'll be continuing on with tokenization, scanning, and parsing after the jump of the midterm. And this will get us towards being able to then take our parse tree of output and run commands based on it. Like once we have the structure of some input, we can then go take action given that input and carry out the commands that someone asked us to do. We've assigned meaning to it effectively.